The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna, for introducing the session. A very good day to everyone, and thank you for joining. Welcome to AI for Good's AI and Machine Learning 5G webinar. My name is Jiaying Meng from ITU, the International Telecommunication Union. Today, we are excited to host another webinar titled Estimation of Site-Specific Radio Propagation Loss. This webinar aims to introduce and explain the challenge problem statement from KDDI, which aims to construct an AI and machine learning model that can accurately estimate the propagation loss during the signal delivering process. In the webinar, our speaker will explain the conditions of this challenge, the data sets to be used, and the evaluation criteria. As always, we are counting on you to help create an engaging discussion. If you have any questions, please type them on the video wall and we will take them during the Q&A session right after the talk. Before officially starting the session, I would like to introduce our esteemed speaker, Kazuki Takezawa-sama. Takezawa-sama is a researcher at KDDI. His research interests lie in radio wave propagation models, specifically using AI and machine learning for outdoor environments and the human body's proximity area, with a focus on advancing towards 6G. And my colleague Vishnu, who will be taking charge of the Q&A session. Without further ado, I would like to pass the baton to Takezawa-sama. Takezawa-sama, the floor is yours.
Thank you for your introduction. I will share the screen, so please wait a moment. Is it okay to start? Yep. Again, I'm sorry. Hello, I'm Takezawa from KDDI Research. Today, I will explain the challenge problem, estimation of site-specific radio wave propagation loss. Yep. And to begin, let's discuss the background. In order to provide stable mobile communication to users, it is necessary to consider factors such as the positioning and the orientation of antennas. For these purposes, understanding the site-specific radio reception condition is very crucial. These reception conditions vary from place to place due to the influence of the environment, such as the buildings, and can be understood by knowing the radio wave propagation loss. For instance, as shown in the image below, the blue line shows the waves reaching the device directly when the base station emitting radio waves is directly visible to the user. In such line of sight environments, the propagation loss changes with the distance from the base station. On the other hand, as indicated by the orange line, when the base station is not directly visible, radio waves reach through reflections and deflection, by surrounding environments such as buildings. Here, deflection means the phenomenon of going around the structure. In these non-line of sight environments, radio waves reach through various pathways, and the propagation loss changes diversely from place to place. And page 3, conventional radio wave propagation model. Until now, models resolved by measurement data and statistical parameters such as an average building height and average roll width have been used. Although these models match the statistical evaluation of the location as a whole, they fail to consider the unique environmental information of each individual spot, leading to differences with actual values. For instance, in the extended Sakagami formula shown below as an example, calculations are made using parameters such as roll width, the height of nearby buildings, and the average height of buildings between the transmitting and receiving points. However, it is inevitably results in a discrepancy with actual conditions because it cannot fully represent how each receiving point is surrounded by structure and how radio waves reach them. Then, AI-based radio propagation model to solve the challenge of not being able to fully consider this environment-specific information, AI is beginning to be utilized. Methods are being explored to model the relationship between environmental information extracted from map data and separately prepared propagation loss data, aiming for more accurate estimation of propagation loss. Then specifically, as shown in the lower left learning phase, we extract parameters that quantitatively represent the environment of each transmission and receiving point, including information such as distribution and location of building. They're derived from environmental data. Yeah. Then using these parameters, we conduct learning using measured or simulated data propagation loss as training data. Next, in the estimation phase on the lower right, propagation loss can be estimated by inputting the parameters extracted in the same way for environments not used in the learning phase into the model. And page 5, consider points of constructing the AI model. Now, let me explain the consideration for constructing the AI model for radio wave propagation loss. You will be asked to consider 3 main aspects. The first one is characteristics of environment, features of environment. Second, parameters extraction method. And third one, the learning model. And below is example to make it easier to understand, but feel free to explore. And then the first one, for the characteristics of environment, as features representing the environment to be used as a parameters. Please consider characteristics of the environment that are likely to correlate with propagation loss. For example, understanding the height of buildings between the radio wave transmission point and receiving point could provide insight into how much line of sight is available or strength of the deflected path bending over the building. The second one, parameter extraction method. In this aspect, please explore methods for extracting and processing these features. For instance, consider quantifying the height of buildings between the transmitter and the receiver at a regular intervals, such as in meters, delving into how these features can be extracted accurately and efficiently. Think about the data representation that will be most effective for the AI to process, such as numerical values or even graphical representations. And the third one, learning model. In the learning model, please consider how to estimate using AI models, such as learning the weights of the neural network that inputs the parameters using the propagation loss values at the same coordinates as the training data. Then page 6, task of this program. Next, I will explain the challenge provided in this program, using 3D map data of Tokyo, Ginza, and propagation loss data from multiple transmission points, your task is estimate the propagation loss from different transmission points. The tasks are divided into three based on the radio frequency. The task 1, basic, is set at 800 MHz, and task 2, advanced, set at 7 GHz, and task 3 is also advanced, set at 28 GHz. As the frequency increases, the influence of the surrounding environment becomes stronger, so making the estimation more challenging. And there are two data sets for the challenge. The first one is 3D map data. This is provided in OBJ file format, processed from open data. Now, please use this data for consideration of what environmental features to use for extraction of those parameters, as I explained on the previous page 5. And then second one is propagation loss data per transmission point. And this data is calculated using ray tracing simulation. Please use this data as training data for learning model and for evaluation purposes. And another important point is that you should not use any information other than what has been provided in the distributed data set. Next, I will explain the method for evaluating accuracy of AI model. The propagation loss data per transmission point in the dataset is divided into CSV file based on the location of the transmission point. You will perform cross validation as shown below for evaluation. For example, in the first row of the cross validation, or just CV1, you will use the propagation loss data from X1 to 3 for training and evaluate using the propagation loss data from X4. Similarly, in the second row of CV2, you will use the propagation loss data from X1, 2, and 4 for training and evaluate using the propagation loss data from X3. Next, let's delve into details of the evaluation method. You will create models using the training data for each CV and perform evaluation using the evaluation data. And the accuracy will be calculated using the root mean square error or just RMSE formula. And additionally, there are 3 conditions for AI model generation. A, for each CV, the evaluation data must not be used for training, only for the evaluation. B, learning and evaluation should be conducted using data from the same frequency band only. For example, a model trained with 800 MHz training data for basic use should be evaluated using the same 800 MHz data for evaluation. And C, the AI modeling method and training method can be freely considered. You are free to decide how much of the training data to use, how to extract the features, and what kind of AI model to employ. However, please do not use any information other than what has been provided in the dataset. And page 9, evaluation criteria for the task. Next, I will outline the evaluation criteria for the task you will undertake. The criteria are divided into 2 main aspects: the usefulness of the AI model and modeling methods. The first one, useful model. For estimation accuracy, we will evaluate how accurately the model can estimate the propagation loss. This will be assessed by looking at the average values across CV1 to 4. The goal is to determine how precisely the model can predict the data. Then additionally, we will check the generalization performance significantly, how consistent the accuracy was. For instance, a model that performs well under certain conditions, but not well under others, is unreliable for estimating accuracy in unknown environments. Therefore, less variability in performance is desired. And a model that demonstrates both high estimation accuracy and consistent performance across different datasets will be considered useful. Then 2, modeling methods. The method of modeling will be comprehensively evaluated based on originality and complexity. Of course, simpler is better. Then page 10, submission requirements. There are 2 submissions required. The first is a presentation in PDF format up to 20 pages in length. You can create it in English or Japanese, but if you win, you will, you will need to recreate and present it in English. It's likely not an issue for those watching this video. And the content of this document should include a cover page, team structures, numerical data of accuracy evaluation, and a description of the model. In this description, please describe how you design the characteristics of the environment, parameter extraction methods, and learning models. And what points you devise. Also include an example of processing time, detailing what kind of environment it took and how long it took. And page 11, the second submission is the data resulting from the evaluation using the AI model you devise for each frequency, which corresponds to the one task. Please submit your files. You're requested to append the result to the 14th columns of the propagation loss data in the dataset that will be distributed. Okay. And further details about other columns in this dataset will be explained on the subsequent pages, page 19. Then page 12. Next, let's discuss the submission method, question and schedule. Submission should be made through the ITU submission form. If you have questions, please use the form provided on this page. This one. Yeah. And we aim to respond within the 2 business days. As for the schedule, the deadline for questions is October 25th, and the application deadline is November 1st, and winner will be decided by November 15th. Afterwards, the winner will be presenting at the TTC during the week of November 25th, followed by a presentation at the ITU in mid-December. Then, from this point, we will provide some hints to assist you in tackling the challenge. We delve into specific example of propagation loss estimation methods and give a detailed description of the dataset. And this page is just a reiteration. Once again, as a part of considering the AI model, you are asked to explore characteristics or features representing the environment and methods of extracting parameters and learning models. In the following pages, we will provide more specific examples of what we have actually considered. First, for the characteristic of environment, we consider focusing on the paths that radio waves align or travels, which correlate with propagation loss. In these paths, as illustrated in the middle picture, there are direct paths, reflection paths of structures, and deflection paths around structures. Direct paths having no obstruction, so tend to have smaller losses. Reflection paths and deflection paths in general tend to have larger losses, although this can vary due to factors such as materials and positions of structures. And as for correlation between these paths and propagation loss, it's evident that the longer the distance, the more the radio waves attenuate, meaning the propagation loss increases. If there are fewer structures between the transmitting and receiving points, the electric paths are more likely to reach, so resulting in smaller propagation loss. Environments where reflections and deflection occur multiple times before reaching the receiver, tend to have larger propagation losses. Therefore, in our consideration, we chose features representing this environment as a distance between TX and RX, I mean transmission and receiving point, and surrounding cone structure. Next, here's an example of how to extract these features as parameters for learning with AI. To consider the position and shape of surrounding structures, it's effective to extract them as two-dimensional arrays rather than just one-dimensional numbers. Moreover, since AI is often adapted at image processing, we decided to represent the data as the images using 3D map data to express the distance between TX and RX and relative height of the surrounding structure with respect to TX and RX. In the parameter images of relative building height shown in the lower right, this one, the color transition from blue to red indicates increasing the height of the structure. Similarly, in the parameter image of TX-RX distance, the transition from blue to red indicates increasing distances. From the 3D map data, various features can be extracted, such as image view from above or 360-degree panorama images. So I encourage you to explore various methods as well. Next, let's discuss an example of the learning model. In training with these images, we consider that models used in image recognition, which can learn efficiently, will be useful. Therefore, we decided to apply ResNet in this case. Next, I will describe the dataset that will be distributed. The first one, the 3D map data, should be used for one, considering the environmental characteristic, and two, parameter extraction method. The data is provided in common OBJ format, which is used for 3D models, and it can be viewed and edited with software such as Blender. However, when opening it in Blender, please ensure to set the coordinate alignment correctly. Import the data with forward equal y forward and up equal z up, like this. Next, I will explain the propagation loss data. There are 12 files in total, divided into 4 files for each frequency. The data is provided in CSV file format. The format of the data is shown in the table below. It includes the coordinate of the receiving points on the 3D model, the propagation loss value and latitude, longitude, and height of the receiver points, and the coordinates of the transmitter points on the 3D model, and the latitude, longitude, and height of the transmitter points. Please use the coordinate on the please use the coordinate on the 3D model to compare the propagation loss values and estimated values from the AI model. Additionally, use the latitude, longitude, and height when extracting parameters such as the actual distance between the transmitter and the receiver. In addition to provided data and example, various other research studies have been conducted in this field. I encourage you to search for more information using keywords such as radial propagation prediction and machine learning. As a reference from our company, please consider the following as an example. The presentation is now concluded. Thank you for very much for your attention. Thank you.
Thank you very much, colleagues, Takasa Vivan, for that excellent presentation. We have one question which is asking whether the PPT is shared, already done. that is already answered. Thank you, Shingo-san. We will upload this presentation to the link, ITU link. So thank you very much. As well as the recording is also available. Recording will also be available. Thank you very much. Maybe if the participants have some other questions, please use the Q&A button on your screen. Maybe I can ask a few questions in the meanwhile. Just the basic questions. Takase-san, is this mainly downlink traffic? Is this the traffic data that you are talking about? Is it mainly downlink traffic, or it does not really matter the uplink or downlink? Can you please explain?
Yeah, please, Robert. It's a lady wave, so it doesn't matter. It's downlink or uplink. It's all the same, completely same.
Thank you very much.
Thank you.
Hassan is asking, can anyone join this challenge to learn? Yes, of course. You can learn this. Learn through exploration, data exploration, and the techniques that the colleagues explained just now. It is perfectly fine to learn through doing this challenge. Thank you very much. Now, maybe while we wait, can I ask about the transmit power levels? The transmit power levels are same for each frequency, or do we assume that they are different for each frequency? Can you please explain?
I think you're asking, it's completely same or yeah. I'm sorry for waiting for you. I mean, it is same or it doesn't matter because it is normalized. So, it's correct. Is this can it be answered? Does it make sense? I mean,
Yeah.
the loss is
Thank you.
no worries. So
Normalized. Okay.
Emission power doesn't matter.
Normalized.
Yeah.
Okay. Thank you. Then I think if anybody else has a question, can I ask about maybe prizes for this competition? ITU, of course, gives prizes, and our prizes certificates are announced in our website. Can I ask from KDDI-san side, can I please ask, are there some incentives for the participants, please?
How much? そこじゃなくてね、ウェブページ出せる。どうしよう。I'll answer from Hiroyuki Shimbo from KDDI Research. The incentive is we prepared two types. One type is the winner team can get the certificate from us with the CEO, our CEO's signature. And in addition, we will plan to provide the opportunity to write paper, maybe conference or journal, etc. If we find the new technical point in your submission. Okay, this is explanation is enough or not?
Thank you very much, Shimbu-san. That is very clear. Thank you. And thank you for arranging this certificate from the president of KDDI-san. That is very attractive. And thank you very much for the opportunity to publish for innovative solutions as well. That is very attractive incentive also. Thank you very much.
Thank you.
I think yes, I don't see any other questions. Maybe some other important points, maybe about published results, baseline published results. Are there some baseline papers or baseline published results for this kind of problem? Is it already studied, which KDDI is already published, or we are not publishing any existing current state-of-the-art results? Can you please explain some baseline measurements in this for this problem, please?
Sorry, I didn't understand the baseline. Is there anyone?
The current state of the art, the currently existing existing numbers or existing estimates for this particular problem. Are there some? Yeah.
Actually, we didn't conduct the estimation for this specific Ginza situation, but when it comes to other circumstances, we made it as a paper and we showed it. So please search for it. Yeah, please read such a papers.
Okay, very good. Okay, thank you very much. Thank you very much for that explanation. I think maybe time series. There is no other question on the Q&A. Maybe you can ask any other question from participant in the Q&A. And thank you, Kanai-sensei, for explaining. If you have concerns while tackling the problem statement, you can ask using the form, and please ask the questions within the deadline so that our colleagues can explain the answer within 2 days. Thank you very much, Kanai-sensei. Now, can I please ask about the time series, time factor in the data? The participant has to analyze the time series data, or there is no factor for time series of data in time series, or there is no consideration of timestamp for the data. Can you please explain that?
Yep. Yeah, actually, the time must be included in a PDF files as a routing below. Yeah, but it's just a reference, not for, because taking too much time is also good.
Sorry, this is time measurement. This is time measurement, but the data that we provide, is it timestamp? Is there a timestamp?
Yeah, but when it comes to the timestamp, it doesn't have. So just the position and the population loss. Yeah. Sorry for misunderstanding.
Thank you much. Thank you much. Thank you for clarifications. I think those are the important questions. I think we have covered all important questions. I don't see any other questions yet or the Q&A. So I think we have covered all the questions. Maybe one last question. Let me ask about validation.
Okay, sure.
Validation data set. KDDI will use some data set for validation when the participants submit the data and the solution. Sorry, when the participant submits the solution, then KDDI will use some validation data to validate the submission, or how are you evaluating the solutions, please?
Sorry, I didn't understand the word what? Radiation? Not, maybe not.
The testing. The testing
validation.
of evaluation. Testing evaluation. Yeah.
Evaluation. Yeah, okay. Please wait a moment. And we need to discuss in our company. Sorry, now I understand the word validation. So we didn't use the validation data. We just use the RMSE for criteria. Does that make sense?
Yeah. So when the participant submit, do you use internal data to check the solution or evaluate the solution after the participant submit the solution?
We don't. I mean, it's a little difficult to say. We just check the. Okay. Pretty much. I'm sorry, I'm back. We do validation for this part, and so every participant must submit result as a predicted PL. So we check it and we
Thank you very much.
Validate it.
Thank you. There is a question from participant whether they can use additional data from the participant, but I think you already explained that the participant must use the data provided and no additional data is to be used. Can I please confirm that again, that participant cannot use any other data?
Indeed, you're right. Yeah, no one can. I'm sorry. You can use only two data sets: the 3D model and propagation loss data. Please don't use any other data for estimation and training AI models.
Okay, thank you very much. Then I think we are who will have rights over IPR since the only incentive is certificate and chance to publish? That is not correct. ITU also has prizes, so please look at our website for our prizes. But IPR belongs, IPR in general belongs to the contributor, I mean the prize, whoever is submitting. So Shinbo-san can clarify this answer. Please, Shinbo-san, do we have a clarification, please?
Yeah, I will answer the question about the patent, right? Yeah. So, patent consideration. So the patent-wise for your submission item is for yourself, not us. Okay. So if you have something patent rights content or algorithm, etc., please get a patent before submission. Okay, this is I think important point. Please consider this point. This is answer from us. It's clear for you.
Thank you very much. That is very clear. This participant submitter has to get a patent before submission, and if there is a need for that, then please do the patent diligence and checking before the submission. And anyways, the rights belong to those who are submitting. The author has the rights. This is also clarified in the ITU website. You can check the IPR clause in our website. Thank you very much. Thank you very much, colleagues, for clarifying as well. That is the end of Q&A. I would like to thank all colleagues for very patiently answering all the questions. Thank you very much. Back to you, Jane.
Thank you very much, Vishnu, for the Q&A session, and Takezawa-san and all the colleagues for your contributions during the whole session. At this point, I would like to thank everyone for sparing your valuable time to join the webinar today. We have more sessions in the future. Please check the AI for Good program page for details. Please also note that the challenge is now open for registration and participation. The link for registration is posted on the video wall. You can start working on your solutions and submit the results on the portal. Several prizes, including the certificates, are planned to be handed out to winners of the challenge. Details are on the challenge webpage. We are also offering compute with GPUs that will be provided to participants based on need. We look forward to your participation and submission. Thank you for joining and have a nice day.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.